I've never seen where she goes pick an apple like.
We'll be doing the beginner session on observing Saturn. I think the big thing that you need to know about Saturn is that it's absolutely gorgeous. There were two main things.
I've never seen where she goes pick an apple.
Okay, Kevin, sit down. You're distracting me. Okay. Hello everyone, welcome to the Winnipeg RASC. My name is Brendan, and I will be doing the beginner session on observing Saturn. I think the big thing that you need to know about Saturn is that it's absolutely gorgeous. Sticker. Saturn. There were two main things.
I've never seen where she goes pick an apple.
Okay, Kevin, sit down. You're distracting me. Okay. Hello everyone, welcome to the Winnipeg RASC. My name is Brendan, and I will be doing the beginner session on observing Saturn. I think the big thing that you need to know about Saturn is that it's absolutely gorgeous. Sticker. Saturn. There were two main things.
I've never seen where she goes pick an apple.
Okay, Kevin, sit down. You're distracting me. Okay. Hello everyone, welcome to the Winnipeg RASC. My name is Brendan, and I will be doing the beginner session on observing Saturn. I think the big thing that you need to know about Saturn is that it's absolutely gorgeous. Do it because, as we all know, if I told you to do it back in the spring, you probably wouldn't have anyway. So now that I'm telling you that you really only have a couple months to actually go out and have a look at this thing, maybe you should pick up that offer. So when can you see it? Now, while Saturn is getting low in the night sky, that's a lot of numbers, I know, we'll get to it. While Saturn is getting low in the night sky, one of the nice things is that so is the sun is setting earlier and earlier as we're proceeding along into winter, fall and then. The numbers that the times that you see here, so September through October, about a month. These are the approximate times that Saturn is setting, and this is astronomical twilight. I won't get into the details of what that means necessarily, but basically it's when the sun is low enough that we consider it dark enough to do a little bit of astronomy. This isn't, when you're looking at a planet, it's not absolutely necessary. Like, you don't have to wait until 9:48 for this to show up. But it's a good reference number for knowing when you can go out and do a little bit of observing. So try to keep that in mind a little bit. But when it comes to planets, you can try and get out and see it early. The brightest, well, some of the brightest, it's like the moon. There's some of the brightest objects that you'll see out there after the sun sets. So it'll be the first things that pop out at you, and they should be still fairly easy to see even shortly after the sun has set. So you don't necessarily need to wait until astronomical twilight, but something to keep in mind. So where is it? Well, right there. This is obviously not the scale, but it's a nice diagram. I like to, when I go out and observe, I like to think about where objects are, right? I think it helps to think about Earth, as the quintessential pale blue dot, kind of floating along in space, and where are these objects that I'm looking at relative to me in space, right? Because when you're looking up at them in the night sky, you don't really get that depth of perspective, right? It's kind of like effectively you're looking at it like it's a static, flat plane, right, at that moment in time. But if you think about it, the planets are actually laid out like this, right? So we're here, right? And we've got Mars over here, Saturn over there. And so if you're looking out in the night sky and you look off in this direction, you'll be able to see Mars and Saturn are actually fairly close together. The reason why is not because they're actually physically close, but because they kind of line up in our field of view, right? So, obviously that is what changes the planet's motion, the planet's position in the night sky as the months go on, and relative to Earth as well. So, if we look up in the night sky, and it probably won't be this obvious, I don't think. One of the problems with these planetarium softwares is I think that they kind of over-exaggerate the brightness of planets a little bit compared to how the eye really sees it. You could probably pick out the 2 planets that are in this right now. Not Earth wasn't counting as one of them. But the 2 planets in the night sky. And they are the 2 bright dots, right? But one of the questions that I think is so commonly asked whenever I'm doing any kind of sidewalk astronomy, or I'm showing people who don't normally do astronomy, a planet through a telescope, right? Like any planet through a telescope. And the number one question that I will ask, or even when I'll be asked, is how do I know? How do I, myself, Brendan, know that that's a planet, right? And I mean, the simple answer is just from knowing the night sky. But there are a few little tricks to it, right? We know that the planets all orbit in roughly the same plane, right? So if you imagine going back to this, right? Now, while this isn't the scale, the flatness of this is pretty close. I mean, planets have a little bit of tilt to them, some more than others. And I can say that because Pluto's not a planet anymore. I'm worried about correcting for that. But this is flat, right? So we know that flat line is going to trace a line out in our night sky. And that line is what we call the ecliptic. I mean, this is the fact that the ecliptic is definitionally the path that the sun traces out in the sky as it moves along, but it's also roughly where the planets will be. So you can kind of see that this just intersects these 2 points of light here. So if you're looking up the night sky and you look to the south and you roughly know where the sun tends to go and the moon tends to go, you can kind of say, okay, yeah, that's roughly where the planets are going to be, right? Now, there are bright stars in the area, so I'm just going to spoiler you a little bit here and say that, and just let you know these 2 are the planets. This little guy is Antares, and you will get tripped up on that a little bit when you're out looking. I think that is probably the most common mistake that I see people make, and I sometimes still make it myself, when I'm just kind of if I'm just firing up a telescope and I don't have any reference points. Antares can, if seeing conditions are not that great, you will happily mistake it as one, but whatever, you just swing over to the other object. So the important things to note here, when you're trying to find it, are that you got to be looking south, right? Well, southwest. Right? West is off over here, so we're looking southwest-ish. And the other thing to note is that you're going to want a good view of the horizon, right? Now, one of the beautiful things about Manitoba, and you can argue with me about how many there might be, but one of the beautiful things about Manitoba is that it's flat. And it's really not that hard actually to go out and find a spot where you get a good southern horizon, right? So you can go off and you can look at these, you can watch planets set for a little bit, right? So, yeah. So try to find a good southern horizon. You could probably go out around 9. Have a look. You can probably get out earlier than this actually. I just picked 9 p.m. as kind of an arbitrary point. I don't know what exactly sunset is, but like 8:30, kind of thing, right? And try to take advantage of it, right? I mean, I think that this is a really good time to go and look at it because you can get in all of your pretty viewing of Saturn and be, mind blown by the rings and everything. And then after that, you can, if you got a good clear night, you're just getting started. You can go off and start looking some pink fuzzies, right? So it's a good way to get the night rolling. One of the really funny things about technology is how bad humans are at picking it up. I have a little pointer here that actually allows me to change slides on the fly. Yet for some reason, I think for about half of these, I've gone back to the laptop and pressed the next button. But anyway, I'm gonna walk away for a little bit. Habits.
Sign of old age.
Yeah, I know. I'm getting up there. So you should see me trying to use an iPad at work today. Throw that. So if we move on to, so now what's happened is we've moved on to October. And so you'll notice that Saturn it's kind of roughly in the same spot, but you can actually get it a little bit earlier and have a look at it. Now, the thing is that it will be rapidly disappearing on us, right? It will be getting lower and lower and lower, right? That's just, unfortunately, the situation that we're in, but keep in mind, Saturn will come back. It will be back. So, you can always go out and have a look at it some other time, but I really do encourage you to go try and find it. And while you're out there, have a look at Mars. We could also talk about Mars tonight, but I just thought we'd talk about Saturn instead because it's the one that's going to be disappearing on us. So, what's it look like? Look at that. Gorgeous. Amazing. That's not what it is. Right? Like, let's be honest, right? I mean, one of the problems with, not a problem, but one of the problems with amateur astronomy these days is that, like, everyone sees Hubble's, pictures and stuff like that, and they expect to see that in a telescope. It doesn't really happen. This isn't even Hubble. This is Cassini. This is a spacecraft orbiting Saturn right now. We've got a picture like this. So it's pretty incredible. Like, it's an amazing planet to look at. So really, what's it really look like? What can I expect to see? Now, all that said, you're not going to get Hubble, but one of the really beautiful things about Saturn is that you can see quite a bit of detail. It has this, like I was saying earlier, it has depth to it, and you can pick out these ring features. And I mean, if you've ever looked at Jupiter, and don't get me wrong, I love looking at Jupiter, but it lacks the rings, right? And those are what give you this depth to the planet. It makes it really interesting, and you can see the rings very easily through a 4-inch telescope. Now, these images are exaggerated. It was just about the best that I could come up with. Just part of the problem is that pictures aren't your eye, right? So pictures are always going to be a little bit different than how your eye perceives them. So trying to translate what you'll actually see to a computer screen is a little impossible. But this is pretty close. Like I would say, maybe not quite as good, but it's close. So the main features to look at, I mean, we're talking about the 4-inch. And when I say 4-inch aperture, I'm talking about the size of your telescope. So like the diameter of it. The main things you can pick up in the 4-inch, if you're lucky on a really good night, I feel like you could probably pick up that band there. You'll definitely see the ring. And even under low magnification, Saturn looks really nice. Like under low magnification, you can get Saturn sitting there in a field of stars in the background with the moons lined up across it, and it's just an amazing sight. For an 8-inch, it's even better. So we have that gas band that shows up quite nicely in an 8-inch on a good night. And there's also this gap here that we call the Cassini division. And that gap is noticeable under good conditions in an 8-inch telescope. So worth having a look at. I didn't include this in the slides tonight, and I should have. But one of the things when you're looking at planets to keep in mind, seeing is really important. If you go to Clear, I put it in the site all the time. It's the Clear Sky blog. I think it's cleardarksky.com. And there will be a seeing parameter on that chart, and that's a number that you really care about for, especially, I mean, as an astronomer, yes, but like for planetary viewing, you really care about that because it's effectively kind of how stable the view is going to be, and that's really going to affect your view of the planet. And one of the things that I will add to that as well is that don't, especially if you've not done this before, don't just kind of look at it and then say, okay, I'm good, kind of thing. Spend some time with it, right? Like, it is a little bit bright, and it'll probably overdrive a little bit if you stare at it for a really long time. But, so try to relax a little bit every now and then. But keep going back to it. And what you'll notice is that the planet your view is changing. And there's a little bit going on in your brain that's helping you to focus on different things, but it's also the atmospheric effects that are clearing off and affecting things a little bit. So, and this goes for any kind of observing. I would highly recommend that you do spend time looking at objects, and not just, look like your eyeball's a camera and take a little snapshot and walk away, right? You want to spend some time soaking it in, and that's how you're going to get the best view. This is a chart of how the rings are oriented. So, because of the way that Saturn orients itself around the sun, we get different perspectives of the rings. Right now, we're pretty lucky. Like this is what it roughly looks like right now. And as you can see, that like back in 2009, 2010, you get this edge on, which is, I mean, we can pretend that it's interesting. It's not. Like, it's I don't. Yeah. Okay. But yeah, so as time progresses, you can. It's something to keep in mind. I mean, obviously, like this is not like what I'm talking about. Like the rings are in a very good orientation right now. And it won't be relevant until maybe 2023, 2024. So like marking your calendars, it's not look good, I guess. But it's important to keep in mind that Saturn's rings do change in orientation. So again, another pitch to go and look at before because time's running out. Yeah. So what causes this? Mostly just geometry. So what will happen here? So if you imagine Saturn's orbiting like this, right? Pretty sure it's clockwise. And then Earth is orbiting like this, right? And so what's going to happen here is if you're looking at it like this, you'll see this orientation. If Earth is looking at it at this point, you'll see this orientation. Now keep in mind, so when you're looking at these things, like you got to remember that it takes an Earth year for us to go around like this, right? So when you go back to this and you see, we're talking about 2000. I don't know what the whole cycle would necessarily be here, but we're talking about 2001 to 2029 here, and you can see that the variation, how long it takes to get through, right? And the reason why is because not only does this take an Earth year to go around once, Saturn is going at a much slower rate. So how these line up is going to slowly change over time. So when you're looking at charts like these, you have to keep that in mind. It's a relatively slow process. It's not like Earth is moving around and Saturn is doing the same. So, did everyone take gravel? Yeah. I don't know. I just thought this was cool. This is basically showing you that image. Oh man, don't look at it. But it's basically the. You can actually see the time here. It's basically what I was describing to you in that chart in animated form. Let's go ahead. But you can definitely see how long, or like this is coming over, like just a year kind of thing, right? So. Anyway, filters. Filters are, and Jerry's talked about them before in other beginner sessions. I won't get into those too much. I just wanted to throw it out there because for some planetary viewing, there are some good filters that you can use, particularly with Mars. And you have to remember, like one of the key things to remember with filters is that filters block out light. They can only enhance contrast. They can't make something inherently better, right? You're losing information. You're just losing more of the stuff you don't care about, right? If that makes sense. For Saturn, you don't really need anything. Like I've seen some people recommend some types. I've never really tried, and I don't really care. But I just thought I'd mention it because it does come up sometimes when we're talking about Saturn's pretty big. I included the banana for scale just in case you didn't know how big the Earth was. Yeah, but I mean, Saturn is a big planet. It's not these rings. I mean, we can fit something like I don't know 10 Earths or something like that across it or something. I don't know. It's big, right? The planet's big. The rings are big. Yeah, big. Speaking of rings, yeah, they're really cool. So we'll talk a little bit about like just how they're laid out and how they look. So, like all things in astronomy and science in general, we like to classify things. Classifying things are interesting to us or others. But in classic form, and this is also classic astronomy form. I love this. So we have the A ring, which is on the outside, and the B ring, and then we have it's steering the D-ring. Oh, wait, now we have an F ring over there. And you can often tell in which ways things were discovered by looking at the numbering scheme or the lettering scheme associated with it, because they never left room for any kind of additional thing. In some cases they have gone back and corrected things. Don't take that as a blanket statement. I know there's exceptions to what I just said, but yeah, it's fine. So yeah, we're talking about this Cassini division. It's 4,800 kilometers wide, and it is. I mean, I'm going to tell you that you can see this because it was discovered by a telescope that was built in 1675, right? I mean, it's not outside of the realm of technology these days. So there's also this ink gap, which I don't actually know if you could ever see from. I mean, you could see it from Earth with a good telescope. I've never done it. I don't know if anyone here has. Never, like, that's outside of my satellite. But yeah, this was discovered in 1888, and it is a noticeable gap as well. And it's caused by a little moon. So this is called the Kilo gap, right? It's this little moon there that's passing through, making that gap in the rings. Oh, I forgot to mention what the rings are made of. We'll see this little rocks and ice particles and stuff. There's not a lot of mass in there. I mean, like, if you were to take it all up and put it together, it'd be about the size of a small moon. Yeah. There's also this Roche division. So there's a lot of interesting aspects to the rings. Out near the end, there's some motion that happens out in the F ring, and it's predominantly caused again by little moons passing by and just causing that material to get spit up a little bit. So it's quite an active place. And speaking of active, it does have a very Saturn has very active aurora. I mean, obviously you're not going to see this, but it's cool to know that it's there. It's another thing I tend to do a lot when I'm looking at stuff through my telescope is I like to think about what it, like, not just what I'm seeing, but what it actually is and how it behaves. I find that adds to the experience quite a bit. Saturn's got a lot of moons. According to my note here, it's got 62 of them. That might have gone up. It's been a while since I've updated this. Yeah, so from the left to the right, we have Mimas. I used to be able to do this. Mimas, Enceladus, Tethys, Dion, Ray, that's Titan, no, that's Ray, sorry. And then that's Titan, obviously. Titan's a big one. That's Iapetus, and that's Greek names. No good present. There's no. You can't have a presentation without, like, no good presentation doesn't come without a chart. So we've got the number of moons of Saturn. You can kind of see when Cassini showed up, because the number skyrockets quite a bit around here. Yeah. I think this jump might have actually been from when Hubble was looking at it or something. Yeah. Observing moons. You can actually see most of them through at least an image field. They're not as noticeable as Jupiter's Galilean moons. Those four are really, really obvious. When it comes to Saturn, Titan's the one that you're going to pick up on the most. With a good sized telescope and some good magnification, you can see quite a few of these. Yeah, and Titan's really cool. It's the only natural satellite outside of, well, actually, it's the only natural satellite to have an atmosphere. It is 50% larger than the moon and 8% more massive. So our moon is 80 in comparison. Enceladus is also a very cool place. This is water shooting off of it. So to have gone out and found water shooting off of this rock, I think is pretty amazing. And they've come up with some theories on why this happens. What they're supposing is that there's tidal heating being caused by effectively being caused by Saturn, I think. And what that's doing is generating this. So there's liquid, liquid water that gets, generated as a result of this heat as it melts, and then just finds its way through a crack and forces its way out. I have this as a wiggle feature on it that I was looking to show off because it was neat. That is a moon. Yeah, there you go. Somebody got the joke. You guys seen Star Wars? It's lesser known film. One of the things I love to do too is, and you guys are just getting a line on the system, by the way. I love to look at the history of astronomy. So I love looking at how things were seen back, in the past, right? And these are drawings from Galileo, Huygens, and Cassini, and you can kind of see how telescope technology was also evolving, and also just that, I don't like this was an effect that was happening, and then this is kind of on the ball. This is pretty good, and I don't know what Huygens was doing with these things. There's a little bit of aberration, I guess, that can happen, but Cassini's, you can notice the gap here, right? So that's the Cassini division. So Cassini was very clearly picking up on that. A little bit of space history, just for the heck of it. We've got a few minutes left. Pioneer 11, launched sometime before the dawn of the dinosaurs or something. Sorry. It was. I got it here. It was launched in '73. Reached Saturn in '79. But this is actually craft that discovered that effort that I mentioned. So we couldn't see that from any ground-based telescope. So what happened is we sent a spacecraft there and found it, right? So, Voyager 1 and 2, very famous. Took a lot of cool pictures and stuff. And Cassini. Cassini is an amazing mission. Most of the pictures that you saw tonight were taken by Cassini, which is an amazing spacecraft currently orbiting Saturn, but it will be retired on September 15th, 2017. And that date is pretty specific because that's when they're ending it. It's not even a funding issue anymore. It is, the system is basically run out of life. And what they're actually going to do is they're going to take it through. They're going to take it through the rings, just to get some good science out of it. And then what they're going to do is they're going to launch it into Saturn, just to prevent any possibility of it crashing into one of the moons and potentially affecting introducing any kind of biological contamination. Huygens was a little probe attached to Cassini, which I think, I'm not sure if I can see it there. Anyway, but Huygens was attached to Cassini, and it was a little lander that parachuted down onto Titan. Remember, Titan has a nice thick atmosphere, and in previous times that I've given this this presentation, I've actually had to do this manually, but this time I actually have the sound hooked up. So one of the coolest things about Huygens, and I don't know why enough, people don't really talk about this a lot, but Huygens actually had a microphone on it. Now, there have been microphones on other landers that went to Mars, but they unfortunately failed, so we don't have sound from Mars. But we have sound from Titan. And if I don't screw this up, I will let you guys hear it. I'm just going to warn you, it's not accurate, but it's cool when you think about it. So, it just sounds like static noise, right? But give yourself a moment and think about where this is coming from, right? This is, currently what we're listening to is a little spacecraft that humans built that is landing on a moon orbiting Saturn that has never seen anything human-made before ever, right? And we're just recording sound of that as it's parachuting down on it. I think it's cool. Also, Titan has like some methane on it. It's actually really like one of I grew up in northwestern Ontario, and does that ever look like Superior? Maybe the outline of it and everything like that. Titan's a really, really fascinating place, and they've done a very good job of mapping it. And I really hope that in my lifetime that we do manage to somehow get something else back out there, because I think it's a really cool place to see. Yeah. Yep, you are right on time because I'm done. Thanks, guys. I think I turned down the right volume, but just in case, be prepared.
Somewhere in with all those icons. Okay, well, welcome to the September meeting of the RASC Winnipeg Center. How many of you have not been here before? 1, 2, 3, 4, 5, 6. Pretty soon we're going to have to start restricting membership. Get up there. I guess we're going to pass 200, and then we'll have to send a third person to Toronto every year. Anyway, welcome to the September meeting of the Winnipeg Center. We've already seen a part of our meeting, the beginner session that we have that starts at 7 o'clock. Originally designed so you could bring your kids in and sort of get them conditioned to spending a lot of your money later on in life online. So tonight we're going to go through our usual schedule. Announcements that I'll put up first. Brian is going to talk what's up, which is what's coming up in the next month in the sky. I'm going to talk about what's been done in science of astronomy over the last month or so. And we're going to have a little bit of a look at some of the photographs from the Sprucewood Star Party, which we had earlier this month. Most of you were probably at, and Brian's waving at me frantically, which probably means he didn't bring his pictures.
No, actually I did.
Am I right? No, you got them. Okay, well, I'll get you down here when the time comes. And then we take the best part of the meeting, the cookies and coffee that put together by some of our more dedicated members. More goodies today. Oh, two contributors, the high caloric coffee, this astronomy, and you'll find that it was true because you need that energy when you're up there. The cold skies of winter. And then after the break, Stan and I are going to get together and talk about where you might want to go next year in August for the total solar eclipse across the United States. It's something that I asked you if you wanted 2 meetings ago, and so we decided to put it in now when it's still got time to make some plans. For those of you who don't know me, my name is Jay Anderson, and I'm currently the president of this center. Announcements. Well, Sprucewood Star Party is completed. It was pretty successful in all aspects except the weather, and it wasn't terrible to the weather. It was just not as nice as we would have liked it. And I'd like to acknowledge the people on this list who were the ones who put it together, particularly Sylvia and Jerry and Mark. The work that goes into producing the Sprucewood Star Party starts with the committee. It starts with the funding that Cliff looks after. But it involves a lot of organization, getting people to provide us with the dinner that we have, getting the facilities arranged at Sprucewood Park, getting the people at Sprucewood Park who are under quite a severe staff constraint right now to set up the field for us, to mow it, to bring out the porta potties and sort of make sure buildings are open where we can charge batteries and things like that. And then there are people who provide casual, on-the-spot help, assembling tents, and basically helping out with the organization along the way. And the main players are, I think most of them are on this list here, but there are many others who helped along the way. In fact, just about everybody who went out to Spruce Woods was involved in some way in helping out. Do we have a count on how many came out, especially, you know?
53. 53 came.
How many?
53.
53. Must have something to do with that rain on Saturday night. Anyway, Spruce Woods Star Party Committee is always looking for other volunteers who'd like to help out. Cliff and Sylvia and Jerry have been involved for a long time in it. And one of the themes of tonight's meetings is to bring in some new blood and new volunteers into the affairs of this center. We have a replacement. We have a new person in the University of Manitoba who is the newest astronomy instructor. Danielle here. There she is over there in the corner. Danielle is going to become a big part of the RASC Winnipeg Center because, you know, we interface quite intimately with the University of Manitoba, and especially in the use of their land. And we have our observatory at Glenleaf, but also this facility and some of the other things that we do. And in exchange, Danielle is expecting us to help out with the open house that takes place monthly over at the UN Telescope on top of the University College. We were doing that last year. Some of you, many of you, attended it at one time or another. Some of us were there monthly to help out if we could. And that's going to start up. But this time it will be on the last Wednesday of every month in order that Danielle's schedule will fit in. So, Danielle, welcome to Winnipeg. Welcome to the RASC Winnipeg. And we'll certainly be talking to you great. Got a note from Jennifer that she's settled in Toronto at the moment, and appreciate she's greatly missing her cats. In January, we have elections. And just about all of our positions are open, except there are only 2 councillors who were elected last year whose term will continue into the next year. So the following positions, all of the current incumbents are eligible to stand for re-election. But we won't want to take the easy way out on this. We need a little competition in this sort of thing. So we have The only person who I know for sure is not going to stand for re-election is the one on the top of that list. And I think it's time you got somebody new in this position. In the past 40 years, I've been president for 3 of them, which is way too many. But I've been on council for most of it. And the other positions you see there are open. We've had some indication that the incumbent will stand again, but we'll still take volunteers and nominations. We need 2 national reps. Is Dennis here? Where's our national reps? Are they here? National rep mostly sits on Skype 3 times a year and listens to a national council meeting. And we will fund or partly fund a trip to Toronto for the 4th meeting that the council has every year, generally during the General Assembly of the RASC. So I'm not sure whether our national reps are going to continue in that position or not. We may have an election for 2 of them. So it gets occasionally tedious sitting in and listening on Skype to these, or by the telephone to these national meetings, but you'll find some very interesting things that happen at national that maybe open your eyes a little bit about how much organization there is in the background to keep the RASC running. I mean, we've been around for well over 100 years, so we must have discovered how to do it. And of course, you get to vote on whether they increase fees, which seems to come up pretty often. We also have appointed positions. Winacentrics editor, observatory director, webmaster, and the telescope coordinator. They are not up for election, but I would like the persons who are currently holding those jobs to confirm with me that they're going to continue. Those are appointed positions, so the council will confirm or pick new people for those positions depending on the circumstances. If you're on council, well, of course, what the secretary does, what the treasurer does, they're pretty straightforward. What the president does is what you see me doing here. What the vice president does is a bit of a mystery. He is here. He does do the beginner session, but it's not a necessary condition of being vice president. He fills in for me when I can't be here, or past president will do that. And then 3 councilors mostly attend the council meetings and give advice. So I would say that the biggest job for people on council, at least in the last year or 2 years, is to come to my house, drink beer, have snacks, and talk over things that are going to happen, and occasionally spend a little money on projects and other things that we have to do. So Chris has volunteered to take names, so he's just gone out right now because we have some books to give away today. So we have books to give away today, so during the break, make sure you have 10 tickets to place in front of the books that you like to distribute them how you wish. And we'll have a draw for them. These are donated by Jennifer, who left them behind when she moved off campus. Chris has also volunteered to take the names of those who are interested in being members of council or members of the center executive. And that includes people who are incumbents in those positions. And we will hold elections in January. Try not to miss them this year like we did last year. The Nature Conservancy has, as you know, invited us to make use of their property near Tolstoy. And we are actually going to do that. Megan Osterman and Dennis Lyons have both agreed to take on the task of organizing it. You may have seen some memos from them already on the discussion list. But they're planning to go on the new moon near October 1st, go out to Tolstoy, or not, it's actually close to Stewartburg, and set up telescopes. And I noticed today there was some request about whether or not the building that they have there would be available overnight. What kind of weather. It's really a test case to find out if they have the willingness to provide us with the facilities that we need to use the site for getting a really nice dark sky. Are we going to have access to warmth? Are we going to have access to power? Is there going to be some control on lights? Well, they want to make that into a dark sky site. It's 22,000 acres. There should be room on this board somewhere. But first, the start will be in the grounds of the rather exclusive building there. This is the Weston Family Tallgrass Interpretive Center. And if you take a look at this Google map, I've shown you the route south of Winnipeg past St. Malo and into the site itself. And I'll zoom in on that in a minute. But the St. Malo, a number of us observe in this area already on some of these back roads. So the trip over to the Weston Dark Sky site, as we could probably start calling it, is not very much further along. So it's about an hour and 15 minutes out of Winnipeg, 106 from downtown, probably about 95 from the perimeter. And when you get to Stewartburn coming in here, it's up here and then to this road. So once you get to here, there's signs that tell you where to go. And this whole acreage in here is part of it. You can go zoom in on that and find the buildings itself that form the core of that piece of property. It's a nature site, so it has more attractions in it than just the absence of lights. We'll see how it works out, how willing they are to accommodate us. In the back of my mind is the next time our observatory floods, we may say, I'm finished with that Glenley site, and maybe we can move out to Coastal. Keep the pad and the warm room at Glenley, perhaps move the telescope to something darker, but that'll be something for another president to decide. For those of you who are new, we have an observatory at Glenley, and all members are able to use it. It has a 12-inch telescope in it and has a separate 14-inch telescope that's stored there, which can be pulled out and used. And we're talking about putting a permanent place for that, so it just has to be opened up and used. We also have telescopes for loan. This is one here, I guess.
Yes.
Yeah. Is this available?
No.
No, it's not available. We have a lot of people who have a desire to borrow telescopes. There's no charge for it. You can keep them for a month. You should see Stanley's if you want to book one for next month.
They can also go on the website, on the RASC Winnipeg website. There's a place where you can go and send a message in, and then we get that message gets directed to me. So you can talk to me here, or you can do it from the website.
So you'll know Stan because he's going to be up here with me.
He's also quite loud.
I thought while I was getting a picture of Weston, I'd also get a picture of our observatory. So here we are. For those of you who've never been out to Glenley, this is the university's observatory, and this is our observatory. And we have the most important facilities right here because that's where the washroom is. In fact, I think the university allows us to stay out there because we provide them with a washroom, and that eliminates all kinds of other legal requirements for university facilities. Winnicentrics is our newsletter. Most of you got that electronically. We use the mailing list with National to distribute it. So if you don't have a valid email with your registration with the National Center, then you won't be getting Winnicentrics, which is, it just tells you about these meetings that are coming up, and usually has a collection of Sheila's pictures and anybody else happens to send them in. We also have the email discussion list. This comes up all the time on how do you get onto it. So there it is, that address, and that's also in the current issue of Winnicentrics. So if you want to make sure that you're listening to the discussions that we have and the little events that happen, and sometimes the spontaneous start parties when a new comment pops up or something like that, then you should be on the discussion list. If you're interested in astrophotography, that's where you'll find the people who are doing it and can connect in with them to sort of foster your own interest. Having done that, and I'm now at the end of that section, so I want to reiterate again that we're looking for candidates candidates to fill positions on the Winnipeg Center Council for the election in January, and Chris will take your nomination. Now, I believe I have Brian up next. Do you remember Brian? Let's start over. There you go. You want to hear me?
No, you gotta turn, I turned it off, you gotta turn it on.
Thanks. May you turn it on?
We'll switch it on.
Okay. All right. My name is Brian. I'll do what's up for September. Okay, so we have the planets. Okay, so Mercury's well placed in the sky. Venus is shining brightly in the western sky at sunset. Mars and Saturn are pretty low in the evening. I'll show you how. And of course, Jupiter is going to vanish quite early in the evening. Now, this is the top view of our solar system here. So we got Jupiter right here, and we've got Saturn and Mars. There's Mercury right in front of us, and there's Venus. Okay, so we'll take note of especially Saturn and Mars, and then Jupiter, because what I'm going to show you next is. All right, so here. I can take note, there's Mars and Saturn, that's why they're so low in the sky. Jupiter is already set. I think Uranus is probably still up here, and that's about it I have. But one note I want to make is this is supposed to be tomorrow, right? Saturday. So what constellation we have here, we have, really showing up too brightly. We have Hercules, we have Lyra, and Pegasus. And of course we saw three big objects there. I think it was Mercury here. We saw, was it M57 was pretty bright there. So that's for Remembrance Night tomorrow. Now, this is what's going to happen for the next month. But I have to include Dragon meteor shower for October 20 or October 7th, because for our next meeting, we have, of course, Mercury. I made a note here for the last quarter of the moon because moon sets around about 3:45, so right about that time after September 23rd, we can go back to your deep sky imaging or observing. Of course, also too, we have the zodiacal lights coming. So we have until September the 13th to see it, but it's in the pre-dawn, early morning. And it'll start up again around September the 29th, and 2 weeks after that. And we won't be able to see it again until the spring of next year. All right, I just kind of threw this in here because I thought it'd be kind of nice to plan out your observing for the next month. The moon is your target, that's great, you know, but for me, I guess until this week, I'll probably start out my deep sky observing for imaging. Okay, so the zodiacal lights here, I know we have some new members here. Probably not too familiar with it, so of course it's the okay, so we have, they're various sizes of the dust. They're very, like, probably just a few atoms to pebble size. The zodiacal lights will appear as a soft radiant pyramid of white light. It's actually quite big. I've seen it in Arizona back in April. So it's actually quite bright and actually it's quite big. But if you don't have as really good dark skies and the moon's out or the transparency is not that great, then you won't be able to see it. Okay, now, of course, it follows the elliptic path of the sun. I'll show you what I mean by that. Of course, the geometry has to be quite right in order for you to actually see it. Now, I added this because the only times you really see it is February, March, and August and September. Now, for February and March, it's going to be the early dawn, and then on August, September, it's going to
Taking pictures of that, yeah. So people may want to take this opportunity.
Okay, yeah. Okay, good point. Okay, so now, okay, so
That's
that's
what's
what,
adding for you. That's a picture of it.
yeah, it's a picture of it right there, yeah. I didn't use the one from Arizona because I still
No,
working
but
on it.
that's a little farther south from Australia.
Is it? Okay. So
You should have recognized the constellations.
So, anyways, okay. This is how you're supposed to see the zodiacal lights here. Okay, so it's this one here is best seen before the pre-dawn. What else do I have, right? Some of the brightest parts will exceed the luminosity of the center Milky Way, right? Of course, moonlight, haze, light pollution will ruin your chance of seeing the lights. And of course, even the most inexperienced observer may get confused, but actually I was told that even some of the professional astronomers haven't seen it yet. All right, so this is what, okay, so I talked around 5 o'clock in the morning, it's supposed to be pre-dawn here. So this is the path of the sun, so I'm guessing it's going to be probably about this big right here. I haven't seen it from up here north, this is Arizona last time I saw it. So roughly about 5 o'clock, just before the twilight hits, you'll be able to see it, hopefully. Actually, I should try a picture of it. Now, what do I have here? Okay, so again, for observing what we have for constellations. On September 23rd, of course, the moon is already set at some point. It was 3:30, I said, 3:45. Okay, so again, it's 1 hour earlier from September 10th. So again, we have, actually, let's see, there's Hercules, there's Lyra, and Pegasus right there. Of course, on members night, of course, we'll be able to help you out for the newer members who are kind of new, because you're not really too familiar with the skies, or maybe you are. For some of the objects like M13 for Hercules, M57, which is really nice. Now it's actually directly above us. And of course, we have the Andromeda Galaxy. What else do I have here? Okay, it's just a little history about the draconian meteor shower here. Some says it will peak around the 8th, but it should peak on October the 7th. Something to watch out for. Of course, it crosses comet 21P, I can't remember the names anyways. And of course, the comet has a orbital period of about 6 years. All right, here's a simplified version of where to find it. And of course, we have the Big Dipper here, Polaris, and that's where it is, right? The constellation here. That's already important, but of course, most of us has experienced a meteor shower before. They'll be all over the sky. So I'll have 2 cameras going probably, and hopefully I'll catch something. Now, one point I want to make is when I was researching this was it's supposed to be a minor meteor shower, but actually I think 2013, around there, I think we were getting about 600 per hour. So I don't know why the handbook says it's be a minor meteor shower, but other years, earlier, we were actually getting a few hundreds. What else do I have here? Okay, now, this is probably what, 9 o'clock I think it is, right? 20 meteor shower here, October the 7th. So let's look at it properly without a simplified diagram. So we're looking at north here. So we got the Big Dipper here, right? We got Polaris, and this is not really showing up too well. There's your constellation here. Now, at 2 o'clock in the morning, I kind of found out this. So this constellation here is actually going to move lower to the sky here. So roughly about 2 o'clock in the morning, it's going to get a little lower than that. And do I have anything else to say? No, I guess that's it.
I didn't mention it, but Brian has the observer members night tomorrow night. On the Saturday following every meeting, there's a members night at Glenley Observatory where somebody will open up the observatory and set up the 12-inch telescope or help you with your telescope if you have one. So if you'd like to go out there and participate, what time are you going to start tomorrow, Brian?
I don't know if I'll be able to make it tomorrow.
If it's cloudy, of course, it doesn't go. Is anybody going to be there?
It's got a moon out, right? So it's not going to be very
Just quarter moon.
quarter moon, yeah, the first quarter. I have the Dragon Boat race tomorrow and another commitment, so I was going to schedule it for next weekend.
Excuse there. What's new? What's been happening in the last month? A lot of stuff. We have so many astronomers in the world that there's always 200 or 300 things that pop up. I never know how many of them actually make it into the various websites, university announcements, and so on. The big event, of course, is successful launch of OSIRIS-REx yesterday. So Ed Plutus of the University of Winnipeg is involved in that project. He's going to be giving us a talk about it likely in November or December. But Ed is one of the researchers who has a project on board the spacecraft, which will take a number of years to get to the asteroid Bennu and then bring back the sample on it. And who knows, someday maybe he'll bring in a chunk of the asteroid, although it's probably worth more than all of the gold on all of the people in this room and what they have in their wardrobes. But nevertheless, it was nice to see it go up. I guess Brendan watched it because he sent a note out about it. Anybody else watch the launch? Yeah, I know. It's very... Yeah, it's pretty. That rocket looked awfully small to me to be going all the way out to the asteroid with a satellite, but when they ignited the engine, it didn't look like it was short of power. So what's happening? Well, we're going to take a look at the largest asteroid out there, Ceres. And in fact, we're going to look at one particular mountain on it, which is called Muna Mons, or Mount Amuna, or presuming that I pronounced it correctly. Here it is here. And there's lots of craters on that asteroid, but there aren't very many mountains. In fact, this is the only mountain. 4.5 kilometers high, 20 kilometers at the base. Seems to be relatively young. We'll tell you why they say that. It's got all kinds of little fractures and stuff falling off of the top of it. And it sort of looks like thick gooey material that's oozed out of the center of this asteroid and then solidified. And so what's happened is, first of all, we have this lovely picture taken from the Dawn spacecraft. And it sort of looks like a kind of icy boil on the surface of that planetoid. And of course, it didn't take very long looking at that to decide that it was probably an ice volcano or a cryovolcano. So the problem was that kind of ice is, because it's a gooey and it flows, to actually have it stay there implies that one of two things. One is that something is really stabilizing it and making it solid, or that it's got a temporary existence and we just happen to be there at the right time. We don't like to invoke temporary existence because that means that the interior of this rather small body has to have something liquid or have had something liquid in recent years. So what they do is what all scientists like to do is they make a model and they keep diddling the things in the model, adding a little heat here or a little more gravity there and so on and so forth, throw a little more salt water in underneath until they're able to build something like this. And that's what they were able to do. They came up with an ice-salt mixture of high viscosity, so it would have a lot of other stuff mixed in with it. And of course, the temperatures at this distance from the sun and on that body are pretty cold, so their ice is a lot harder than the ice you and I are interested in and experience with. So it does indeed look like it has extruded out of the lower regions of this asteroid. And then, of course, the first question you have to ask is, how did you get liquid slush below the surface in a body that's that small? We see it in some of the moons of Saturn. You saw an example of it in Brendan's presentation in Enceladus that had that icy plume coming out of it. So we know that the twisting and churning caused by the tides as it goes around Saturn are stirring up and warming up the insides. But this asteroid is out quite a long distance away, and the tidal forces on it have to be relatively minimal. So how did we get something that's that icy enough to flow outward? One of the clues might be is that exactly the opposite side of Ceres is the large crater, the largest one on the moon, and it's possible that when that came in, it actually heated the opposite side temporarily of the body, so that this volcano was able to erupt from icy material, which would normally be too solid to do that. Well, whenever you see something like this, you say, oh, that's a Hubble Space Telescope picture of a globular cluster. And they zoomed in so much, and they get such clear vision, but it's pretty hard to tell which one it is, and because they all start to look the same. Except this one doesn't look the same. You've seen globular clusters, and if you go out to the observatory tomorrow night and the big telescope is operating, you can look at globular clusters, and you'll see this one is very scattered. There's no concentration of light in the center of it at all. It seems like the whole thing is almost like what we would call an open cluster rather than a globular cluster. Oh, great computer. It doesn't seem to want to do that in any fashion. All right, let's see what's happening. The picture I'm seeing on here is not the one that is on that board. Let me start this. For those of you who are wondering, the cat is there because Gail had this thing about the cats. So we, okay, now I can't get rid of the cat. Oh, that's it. Okay, so here we are with our globular cluster. It's a NGC 6101, which we're not familiar with because it's in the southern hemisphere. But it has that very weak core that I pointed out in the photograph. It doesn't look like the other globular clusters. They're much more concentrated in the middle. So the question arises to the folks at the University of Surrey is, why is this globular cluster different than all the others? Once again, we go to modeling because you can look at all of the stars in it, and when you look at it, you say, well, Certainly they're dispersed. They seem to have a different kind of population than some of the other globular clusters. How could we make it spread out like that, stirred up? And so they said, well, let's put a couple of black holes in it and see what happens. Well, they put a few hundred black holes in it, and sure enough, it stirred the pot enough that they were able to get that kind of shape or design to that particular globular cluster. And so here they run the model without any black holes, and they get a cluster. It looks like the real thing, but it isn't. It's actually a model. And they let it evolve through 12 billion years, and not in real time. And this is the shape they get. But then they ran it again with the globular, or with the black holes in it, and that's the shape they got. So there's quite a difference in the dispersion caused by essentially the stirring. Now these are stellar mass black holes, so they're sort of Earth-sized bodies in there with the mass of a sun. They're running around. The globular cluster is old enough that a lot of those stars would have evolved into the final stages, and some would have been supernovas, and those supernovas would have created black holes. And then the question is why aren't all globular clusters like that? But they didn't answer that question. They just came up with this one. So it's an interesting premise. And of course, the headlines say hundreds of black holes discovered in globular cluster. Well, of course, no black holes have been discovered in that globular cluster. What it should have said is, if I throw hundreds of black holes into a globular cluster, it starts to smear out. But it brings up a big point. Modeling is probably as revealing these days in astronomy as actually using the telescope. What they've done in this is they looked at the real thing and said, how do we get this to happen? And made a model. They could just as easily have thrown a whole bunch of black holes into a model of a globular cluster and said, okay, now let's go look for a globular cluster that looks like that. And especially when you get into cosmology or particle physics, if you want to go there, then the power of mathematics to reveal the internal structure of things is quite amazing. And here it comes again. This is Terzan 5. This is a cluster I'd really like to have a look at. This is an interesting cluster. It's in the middle of the Milky Way, but it's in a hole in the dust and gas, so we can see through it and see this globular cluster. The difference is this has a huge range of ages, and remember we had a talk about globular clusters some half a year ago where it pointed out that some of them have two populations of stars, as if there was an initial burst of star formation, and it paused for a while, and then there was a second burst of star formation. And typically in a globular cluster, the first burst of star formation is supposed to clean all of the dust and gas out of it, and there's nothing left for a second burst. But in this case, Terzan 5 has two fairly prominent stellar systems that indicate that there were two bursts of star formation. The interesting thing about it is not that there are two ages, but that those stars are, that population of stars is very, very similar to the stars in our galactic bulge. Now, the galactic bulge is this part of our galaxy here, this sort of central circular area. We have rings or spiral arms that go around the galaxy, and we have this large halo of sort of very old stars that surround the whole thing. And typically, the globular clusters are very old collections of stars out in the halo, and they have a different population of stars, different ages, different sizes than the ones in the galactic bulge. And what's happening with Terzan 5 is that the population within that globular cluster is not like other globular clusters, it's like the halo of our galaxy. So the bulge is believed to have formed from dust and gas about 12 billion years ago, And that's about the age of Tarzan 5. But somehow, this globular cluster, even though it's in close to the core of the Milky Way, escaped being disrupted or torn apart by the gravitational field of the Milky Way. And so what it's doing is showing us what the very early physical composition of the halo was like. Because there's a considerable amount of evidence that a lot of the halo material came from stuff that was stripped off of other galaxies that are passing by, usually dwarf galaxies, stripped off of globular clusters, stripped off of things that formed in the dust and gas that were surrounding the core of the galaxy 12 million years ago. So this seems to be a relic that not of a globular cluster population, but of a population of stars that were initially forming in the halo, which formed after the other globular clusters were formed around our galaxy. Very pretty object too. And it is probably worth looking at, take some pictures of it. It should be bright enough and it's reachable. I believe it's in Sagittarius, so we can go, take pictures of it ourselves. Then there's this other question of why galaxies have spiral arms. It's a question that comes up probably every decade. Well, we have all this dust and gas going around in circles around the galaxy core, and you have to think of it's not the arms that are going around in circles, although they are doing that. It's the stuff in the arm. So you get something here that's moving around fairly quickly, and something over here that's moving around fairly slowly. So this inner part of the arm, the stuff in it, is moving much more quickly than the outer part, and that would naturally wrap it up into a spiral over a period of time. But these arms are actually caused by what's called a density wave, and you get a density wave on a highway when you have an accident on the side, and the first guys that reach it slow down to look, so everybody else has to slow down behind them, and then the guys that are out front speed up again, and the next guys speed up, but in the meantime more cars are coming in behind them and slowing down, so long after the accident is cleared away, there's still this density wave of cars that are slowing down to go through the cluster and eventually disperses. The same thing happens at a red light. You know, cars come up to the red light, they all bunch up, and they never seem to be able to get away from the red light as fast as they came into the red light. And this is what's happening here, is that stars are orbiting around, they come up to this density wave, they slow down because of the additional gravity there, they spend some time, and then they go out ahead again. In the meantime, new stars are coming in from the back. So they have an orbit like this. Here's the, these are various parts of the density wave, but let's just say pick the red one. Stars in here are coming in, they're interacting, it's dust and gas that does most of the interaction and forms new stars, and then these stars continue onward. And the ones in here are moving faster than the ones out here, so what was initially a fairly straight up and down arm will tilt over to the sides like that. So the question is that there should be different shapes to the spiral arm depending on whether you've got older red stars that have gone out ahead and have had time to be tilted backward like this, versus newer stars, the bluer ones, which are still in a more upright position. We've been looking for that for a number of years to try and verify that the theory is correct. And in fact, now they've found it by a very careful look at the spiral arms in a selection of galaxies, and they found a separation between the red and the blue star. So it actually is a nice little indication of the density wave theory and how spiral arms wrap up around the star. But at the same time, it also suggests that as these things get out of the spiral arm, they disperse, and so they don't carry the shape of the spiral arm with them as they go farther out. So this thing is always forming with new stuff coming in the back, and so the spiral of the arm itself doesn't wind up tightly very quickly, but goes on for a much longer time period. And lastly, I wanted to talk about the surface of Titan, one of the largest moons of Saturn. And there are dune fields in it. This is taken from up in this section here, but you can sort of see these striations in here and here. These dune fields are dunes of some kind of icy material of methane and a few other volatile substances, grains of hydrocarbons. I mean, to some extent, Titan is like the Earth, except that its weather is caused by various hydrocarbons that freeze out at minus 200 degrees and colder. And so they have grains, and what this tells me as a meteorologist is that there's got to be enough wind in there to actually form dunes, where the current available evidence from Huygens lander was that the winds were very light. So perhaps there are seasonal winds that will do that. And these also seem to flow around the terrain a little bit and up into the valleys. So the Cassini spacecraft will make a few other passes by Titan, but this is the last pass that they make, that they're going to use the radar that allows them to see these details on the surface. It's going to be a very interesting world. There's already talk about going back and exploring it with a lander with more material. And here's the mandatory cat picture. Probably looking for the sandbox. Brian, did you have something about the Spruce Woods Star Party? We got about 10 minutes.
Yeah. Hopefully this works.
Pictures. We're going to just show you some pictures from the Spruce Woods Star Party, just to those of you who didn't go, about half this room, just so you'll be envious of our ability to survive the weather. Of course, Glenboro has a farmer's market on the Saturday, so we went down to it, and there's I don't know how much corn was ordered.
6 dozen.
How many?
6 dozen.
Okay. Well, I didn't have enough, so we actually had to go visit the Hutterite colony to get the corn to be able to feed us all. And some people oh, are you missing any feet? You're missing feet on your corn. And it was a good one. Sheila sent this picture out today. I just borrowed it off to show you some of the aurora. There was a night with a heck of a lot of aurora in it. And here's a sort of 30 minutes of it. I think the thing you'll notice mostly is how much cloud there was. Most of that thin stuff at the top we didn't even really notice. But when you take this time lapse and have it illuminated from the background with aurora, it really shows up pretty dramatically. Davidian sent this in around the campfire. Handheld, Davidian?
30-second exposure on tripod. No one was moving fast.
Looks like a train going by in the background. That's what you do when it's too cloudy to do any observing. You go back and huddle around the fire and enjoy yourself. Okay, Brian. I'm going to pull it off.
Okay, so this is my version of the time lapse here, the same evening, but 4 hours compressed into about 28 seconds actually. We'll play again from the start. Okay, so that's, and it starts to build up a little bit, the clouds start to move in. Of course, I found out at the end I have my polarized filter on it. There, not much. All right. That should be towards the end. Yeah. All right, let's show you what I have for pictures. Good. Okay, so this should be, actually this is the morning one. Okay, there's Dennis cooking breakfast. That's my SUV. There, so that's early morning. There's Jay. There's Dennis. There it is. Okay. I got well, a few hundreds. I'm not going to stop at every single one of them each time. There's Stan. All right.
I did do that.
Saturday, the best in the morning.
So I did have time to go through over these. So okay, so it's still in the morning. I think I'm trying to get a shot of this light. There's us setting up the tent right there. Jay, Sylvia, getting in it there.
Notice how you're not doing any work by
Works every year. Jerry right there. Yeah, I got a lot of pictures, but I'm not going to stop there. I don't know why it's still getting easier.
Probably the only astronomy club in the world with a wedding tent. Which is available for rent.
I think it was supposed to be a wide angle shot of how many campers were out there. Different angles. I don't know if you can picture that. Okay, so that's Jerry's little sky tour. I think it was on for like, what, 2 hours? You had it on?
Right on the time.
11:43.
Yeah.
And here's another angle of it. Like I said, I didn't really have time to go through all these. Shot there. Okay, so that's the is it opening remarks? On Saturday, I think it was it? Around 1 o'clock. So Stan was doing it. So I got I didn't really have time to go through all this. I was going to pick His name was Ed. Was that Ed?
That was me.
The best shot yet.
I don't know. Taking more shots. Here. I was going to pull. That's right. They're trying to pull a best one. Okay, there's the telescope little tour there. Show you what everyone set up their telescopes. That's the Vivian, right? That's yours. Is that a loader scope?
No, I didn't pull the loader scope, but I just finished the last part of that on Friday morning.
All right.
It's almost finished.
One interesting point that you made was you have these solar panels here,
Yeah.
and then you want to charge it up. I think you put it on the tripod and it tracks the sun. Or is that
Next
something
step,
else?
yeah, next step is to put the panels on the tripod and just fit it in the sun.
So I thought it was a really nice idea. Because,
Yeah.
you know, the panels are always facing towards the sun. All right, that's the Vivian. Okay, so there's Stan. This is Doctor's one. And he was explaining about his power pack was.
Yes. Battery pack.
I don't have a shot of it. I don't have a shot of it. Because the toolbox has the same name as you. All right. Actually, it was supposed to be pretty cheap, $375, was it? No? 25? Really? I thought it was like 300.
The scope is.
The scope was like 375, he said. It was 400 US on sale. 400 US, okay. Yeah, I didn't really have time to go through all those pictures, so. Fast forward. Am I going a little too fast? Well. Can't remember. Al. Oh, wait, okay. Okay, there's Sheila with her telescope setup. She doesn't have that guard staff. Okay. Pictures. Okay, again.
Oh, no.
Like I said, here's only time to go through this second to watch it. There's Andrea with her telescope setup. I had to convince her to do it. Michelle, her telescope.
Homemade.
Is it?
Yeah, I can't call
It
it.
is.
I didn't make it, it's not.
All right.
I have to make brothers.
Oh, I remember this. The here. Oh, is it? You're here? Oh, there you are. There. You questioned me while I was on the floor, so I'm trying to get you in the telescope. That is all too tall. Oh, so that was the telescope little tour that we have. There's Paul. Right, there's the swap table there. After that.
When you start showing rainbows.
We'll do a part 2 later.
We can leave it on while we take our break, so you can peruse the pictures with Brian here. John, you want to finish that? Anyway, it's time for our break until 9 o'clock, and on down, cookies and down here, you can approach them with $12 a month.
If you go online internationally, it'd be 18 plus shipping and handling.
Okay, where are we? Well, next year in 11 months, plus a little, we got a solar eclipse going across the United States. The first eclipse that you've been able to drive to since, I'll stand out of the way there, since 1979, first total eclipse. So back in 2013, Stan and I drove the length of that eclipse from Oregon to South Carolina. Picking up girls along the way. Well, he was. No, wait a minute, he wasn't. Actually, we're mostly talking to, oh my wife here. Mostly talking to chambers of commerce. So the girls we met were. So what I'm going to talk about here is partly about the weather, and partly about the people, and partly about the kind of attractions that you're going to see. But I'm only going to cover everything from the Missouri River west. And for those of you who don't know where the Missouri River is, that's everything west of Missouri. So where are we going to start here? We're going to talk about just a general view of the eclipse. I'm not going to talk about the rhythm of eclipses. That was about eclipse cycles. We'll talk about the weather. And I say, oh no, it's tomorrow. I mean, what do you do when it is tomorrow and you need to know what the weather is? And because it's not working out where you are. And just briefly about photography and a few other related record-keeping things. I'll tell you right now that if you really want to know something about eclipse photography, you need to talk about the lady who took this picture. Who's sitting in the middle of there. Because I don't do pictures anymore. She does them. So here it is. How long did it take us to get from Winnipeg to the start? Oh yeah, the Great American Eclipse. See, bought the t-shirt, bought the hat. This eclipse is going to be a little different than most eclipses. It's going to be monetized, which means that every location along the way is going to try and make some bucks out of it. What would you say, Stan, when we first told them about it at the various chambers of commerce? They kind of said, oh, that's interesting, or
Yeah.
they had no idea what was going to get them. The guys in John Day Park in Oregon, we got lots of parking. They had parking for 50. So here it is. It's just about perfectly aligned to make it available to everybody in the United States. And it's perfectly aligned to make it available for everybody in Alberta and British Columbia. Well, once you get away from there, it gets farther and farther away from Canada. And so for us, the closest place is straight south into Nebraska there, maybe around Lincoln. I don't remember anything about Lincoln.
Although Lincoln City is also expressed the city.
Well, that's right, yeah. So here's the basic details. It's on a Monday, 2 minutes and 40 seconds at its maximum in Kentucky, 1 minute, well, just under 2 minutes on the Pacific coast and 2.5 minutes on the Atlantic coast. And the times are important. I've given them in universal time there, but it's local time that's important in these things. So we have to make the calculations by subtracting the appropriate times, because all calculations for eclipses are done in universal time. So it's about 10 in the morning on the Pacific coast and 2 in the afternoon on the Atlantic coast, which means that afternoon clouds have had a chance to build up in the east, but not in the west. You saw that eclipse in 99, didn't you? 79. No, not that. 99. That's one, the last Saros.
Yes.
Well, you've seen eclipses. A Saros cycle is a cycle that the Babylonians discovered. And so if you saw the one in 99, August 11th, yes, and you did, in Europe, and now you got a whole Saros cycle later. Same sequence of eclipses comes around every 18 years and so on. Another do these pictures. Weather. Okay. This will be primarily for me to talk about. So here are two maps. The morning cloud map and the afternoon cloud map. These are done from satellites. They have a resolution of about 1 degree. So that means 100 kilometers on the side. So they don't really see anything smaller than about 100 kilometers. Which means little bits of cloud and mountain valleys don't show up too well. The first thing you see right away is that the west is better than the east. The blue colors mean less cloud. And generally averaging around, we'll say 15 to 30%. In the afternoon, the cloud builds up, especially down through Wyoming, through, we all know the names of these states, I take it. So Wyoming, where to go? Oh, now you really got me. Seeking in my hand. There it is. So you'll notice that Wyoming gets quite a bit cloudier in the afternoon, whereas the area to the west of Wyoming stays pretty clear. And, well, this is the hard way to look at it. I put this chart together. This is what the cloud looks like from those satellite maps as you go down the center line. You see we've got morning clouds and afternoon. So mostly what we want to look at is just the morning side, because it doesn't actually get into afternoon cloudiness, which is this blue line that passes the central part of Nebraska. So presumably most of us are going to be on this side watching it. And so there's a couple of things you see here. For instance, and I've labeled it all. So we're looking at the red curve. You see this little bump is the Cascade Mountains. This is the Pacific Ocean. This dip here is the Columbia Basin. This little peak is the Columbia Plateau, which is high ground. The Snake River Plain, low ground. Here we have the Snake River Plain Part 2, low ground. Here we have some high ground, which is the Jackson Hole in Wyoming. Here we have low ground, which is on the east side of the Rocky Mountains. Well, this is a low resolution slide, and later on I'll show you a higher resolution slide of these cloud cover that captures some more of the detail in the mountains. But fundamentally what you see here is that if you're going to sit on top of mountains, you're going to be cloudy, and if you're going to want to find clear skies, you want to get into the valleys. And you want to get into a fairly sizable valley, because the one that's around Jackson, Wyoming, the valley that's there, which is called Jackson Hole, the town is called Jackson. You can see it doesn't make very much of a dip in the cloudiness there, only about 4 or 5%. Whereas you get this dip in here in the Columbia Basin, there's a 20% drop in cloudiness in through there. So let's go through this state by state. So here we are in Oregon. Lincoln City is where it starts, which is close to it. And so in Lincoln City, which we're in on this coast here. Here's Newport, Oregon, which is right here. It suffers from the high levels of cloudiness that are on the Pacific. There's a lot of fog on that coast. There's cold water up there. We know all about the fog. Especially in the morning. Yeah. And it does burn off, but it's always lurking there just offshore, and with the wrong kind of wind or maybe the cooling that comes with the eclipse are going to come ashore. And so, when you want to get a couple of mountain ranges between you and that cloud on the Pacific, and there's one range right in here, the Coast Range, and then there's a second one here, which is the higher one, that's the Cascades. And so, you get a little bit of a dip in between the Cascades and the Coast Range, which is the Willamette Valley here where Salem is. You can see a little bit of a dip. But then as you come across the Cascades, it really wrings the moisture out of things, and you get into the Columbia Basin here. And so we end up with, over here is the Cascades. This is the Willamette Valley. You get over here on the other side, in this low ground, this greeny stuff, that's the Columbia Basin, and the lowest part of the Columbia Basin is very close to Madras, which is right in here. You can see that it's almost the sunniest location. You cannot get a hotel room in Madras. You couldn't have got a hotel room in Madras for a year. If you want a hotel room in Madras, it'll cost you $399 US per night to stay in the Comfort Inn.
Minimum 3 nights.
$1,000. So, now mind you, you want to camp. You will not find a campground with any space anywhere in the Columbia Basin. So more likely for camping, you'll have to stay a little north. I mean, Portland's a pretty big place. You can go south into Bend, for instance. Although Bend has got a lot of people staying in it, and it probably fills right up. So if you want to go into the very, very best region out there in Oregon, you're going to have to find yourself some place well off the track, probably up around Portland. There should be lots of them in a big city like that.
Probably if you want to go chasing along.
On the other hand, we did take this road through here.
Yeah. And then once you get to there, then you got Mitchell at that point.
And Mitchell, we went through Mitchell. So, Dan, tell us about this place.
The water is cold. We took a walk down to the beach because whenever I go to a coast, I go take my shoes off and I go and I dip my foot in the water. So this is the first point that anybody in the U.S. standing on this point, right at the edge there, will be the first one to see totality.
And there is the point right there. No, right there. Right there. That's the point. This is the center line. Right here.
And it's almost impossible to get to because it's all that piece of bush that's just on the other side of that.
Yeah, there's a little forest here.
Yeah.
And there's a parking lot right here with room for 20 cars.
Yeah.
20 cars. You gotta get there now to reserve a spot.
And his house is all the way along, so you can just zip to the water, right? You're gonna have to, you can't go through people's houses, and you'll hear more of what Americans not like when we own their property.
And this guy, we talked to him, told him about it. He said, I think he's the one gonna have to invite his relatives, he said?
Yeah.
Said, maybe I'll just go somewhere else. And this is a gated community here, with a big field right here. So I'm sort of curious as to whether a gated community would say, hey, we could make some bucks by letting people stand in their field. Or are they going to say, we don't want none of those strangers anywhere near us? we encounter a little of that.
But then again, you looked at it and you said, you went to talk to that person and said, well, what's with this fog? And he said, oh yeah, it comes in the morning, it comes in to about a mile off the coast and stops.
So here's what it looks like standing on Fishing Point. The center line is right there behind us. And this is this gated community I'm telling you about. And going down to the beach, well, you're not going to do it there. But there's something neat to be at the place where he's the first one. You know, I mean, you'll be on Twitter before anybody else saying, hey, it's magnificent. Or whatever you say on Twitter. Here's a couple of the beaches. I don't remember the exact spot.
They're just further up towards the city.
Yeah, this would be, this is Newport. So these are communities. These are already big tourist spots. But take a look at this picture, or this picture. What do you see up in here, out in here? And look at these people, you know, they're not wearing bikinis. They're wrapped up in sweaters and towels. Now these ones are a little better. This is a little more protected, but even so, they're covering themselves up a little bit. Nobody very much in the water, and certainly nobody up past their knees, because it's cold. And this is wind that's blowing, and this is salt spray and the remains of a little bit of a fog. And so, imagine what salt spray does to the lenses on the Canon camera. So you want to be very careful when you're checking into this place. But it is a sunny spot, even though it's not some of the poorest conditions along the whole of the eclipse track. This is August, and August is a sunny month. And you can see the kind of cloud we encountered, which is pretty common there, but you would have been able to see the sun in the eclipse because these people had shadows under them. And that's a sign that it was sunny enough for the sunlight to get through. I don't know about this spot, that doesn't look very good. So we investigated. Now, the mountains that block the specific moisture are actually right behind, I don't know if I have a picture of it. They're actually right behind this place. They're like 3 kilometers inland, you hit the mountains. And they go up pretty sharply, and so they cut off the moisture. And so you can go into the Willamette Valley, but we went in the next picture right over to north of Madras. Probably one of the best place, or maybe tied as the best place. And this is an interesting story. You go ahead and tell it.
Well, you're driving around, you're looking for a place to park, and we're thinking, oh, you know, near Mattress, this would be a good location. So I pull off the highway and I slowly back the van onto a first highway. Now, I've got the front bumper probably still almost on the roadway, and just barely backed in. We had passed this place and we saw a guy was out there, and he's got he's doing something in the yard, and okay, fine. Well, when he comes to greet us, he's carrying a rifle over his shoulder and no t-shirt. Why he took his shirt off and decided to come greet us with a gun?
Hey, you're in Oregon. You gotta ask. With his trusty dog here. Oh, he says, it's great. Let me put a shirt on.
He's got a big field, so we're saying, you know, people are going to want to come out here, and maybe want to go, you know, onto your property. So So that's an issue.
I took a couple of panoramas. This is boring countryside. I mean, it's flat. It's like the scenic view of down to Moose Jaw from Regina, you know, flat. So there's not a lot to come in there. So this is from close to where, looking over the field where the center line is in the picture we just showed you. This is the place we were slightly earlier. So this is just about a mile away, I guess. This guy's field here. In fact, we stopped in front of this guy's farm right here to tell him that the eclipse was coming. You can pick that one up.
No, we're excited about astronomy. You think you could maybe pass it along? And his comment was, you know, we said a lot of people are going to be coming for this. They're going to be wanting to have locations to stop and set up and look. And all he said was, as long as they don't set up on my property.
I said, CNN could be right outside. Says, just keep their damn trucks off on my property.
And then he went back to the house. You know,
Yeah.
trying to explore what's going to happen. This incredible event's going to happen while you're here. Was not interested.
So just because they're carrying a gun doesn't mean they're unfriendly. The ones that aren't carrying a gun, you got to watch out for. This was a really neat little side trip. We sort of got off the main highway and went north. This place is just south of the center line. This is it's the John Day fossil bed, but there are 3 different John Day fossil bed locations. But this is the main one. You can see they have all of the facilities they need for 2,000 people here. You know, 1 bathroom. Well, 2 because 1 for each male and men and women. So this is a little south of there. So you're maybe, I don't know, 3, 4, 5 kilometers off the center line. Beautiful rock formations and basalt columns and things like that. I mean, the place is just a riot of color. From this point, if you were standing here, the eclipse would be directly above that rock. You have to sort of think of photographic.
That'd not be a nice spot to shoot. You know?
Yeah.
Where do you set up your camera when you get out there? You look for something like that and try to get them to scan with that and some beautiful picturesque object to be.
We told them the eclipse was coming. I don't think they had much of a reaction. I don't remember it exactly, but
Well, I didn't think it was too bad because, you know, they're part of the national park sort of situation, so they're like, well, okay, so I hope the people who are, you know, up here who can do anything know about this because I thought they were excited, but, you know, tainted in the fact that they couldn't probably do much themselves to get, other than just, you know, mention it.
But right now, the American National Parks have organized special eclipse events under every national park that's underneath the center line. So if you're going to camp out in a national park, might be a little too late by now.
Which state are you in here still? Which state are you in there? Oregon. You're in Oregon?
Yes.
Yeah.
This is getting close to the Idaho border. You're in the Columbia Highlands here, so the cloud amount increases a little bit as you go up these hills, but it was still pretty decent. You're still seeing shadows under things, even though there's a sort of high-level cloudiness over top of this thing. In fact, I don't know if it's on this map. Yeah, it's a little bit to the just up in here, Baker City is where you're seeing. Well, I could go back to the Oregon map. These are all on my website. We're into Idaho now. We sort of come down in through this area. We had to drop out of the center line and then come back up into here. You'll notice that there's low ground here and low ground here, and you've got the Sawtooth Range coming across it. So here's the Sawtooth Range and its cloudiness. I'm now looking at that high resolution map that I told you about. So here's the first part of the Snake River Plain in here around the town of Ontario, which is actually in Oregon. And then it comes down, you get to Idaho Falls over here. So these are 2 very, very good spots to watch the eclipse. In Ontario, depending on what data set you look at, is probably as good as Madras. How good is that in terms of your probability of seeing the eclipse? Well, there's one station, Idaho Falls, that actually measures sunshine. Sorry, not Idaho Falls, Boise, and Boise is right there. So Boise in August has 85% of the possible sunshine. So that would be a measure of your probability of seeing the eclipse, 85% without moving. And of course, some of that is sunshine through thin clouds because the threshold of where you cut it off is somewhat hazy.
And your map here shows the 50, but those are like the 10% one.
Yeah, see, that's 50, that's 40, that's 30, and so on.
So now the difference between 25% and some places 50%.
So, I mean, there are some beautiful, beautiful places. I know these folks are getting ready for the eclipse, even though they're on the north limit. I sent a note to somebody that's in here that actually has a sort of rodeo at that time of year, usually in the same week as the eclipse, and said, you could get a lot of people in there if the weather's good to sit in these mountains with the view all around you and watch that eclipse. And he says, look, he says, we get 250 people in here for that rodeo. We're used to handling crowds. Yeah. Well, this is has some interesting places. Now, see, you get out of the plains. Two things you want to do in eclipse. You want to see the eclipse, but you also want to have a little bit of a vacation and see some of the sights along the way. This is one place we like. How many pounds of volcanic rock did we see?
We would not remove any.
Now we picked it up outside the national park.
You picked a very nice place for Judy's.
Yeah. Oops. I think hers might have come from inside this park. This is looking into the Snake River Plain from the mountains of the, or craters of the moon. And so the craters of the moon park is somewhere it's just south in here. And so what you're doing is you're looking from there across the plain in this direction. And that's how you can see it here. These are actually long ago extinct volcanoes, but these dark areas are actually lava flows that make up the crater.
50 miles we drove through the lava flow.
Yeah.
It's absolutely amazing. It's black lava, low kind of, and you look and you say, yeah, it does look like the craters of the moon. Just
appropriate name for an eclipse, but it's actually slightly outside the eclipse pattern. But the thing to point out here is that the clouds, the heavier clouds, all hang on the mountains around it, whereas the area in the center, over the valley itself, is clear. And a lot of these clouds, being convective, and this also is in the afternoon, would dissipate when the eclipse comes along. Then we went a little bit closer to Idaho Falls and sort of took this. You can just tell by the vegetation that this is not a high rainfall area. And in fact, if you look on Google Earth, there's all kinds of circular fields from the irrigation that they have there. It's everywhere you look, really. Then we drop into my own Jackson Hole. Now, this has got a lot of appeal. Casper is the biggest sizable city that's right on the center line. It's pretty full. The American Astronomical Society is having a conference there 2 days before the eclipse for some apparent reason. We have mountains here. Okay, here we are in the Snake River Plain here. Then we've got to get over this Teton Range, and this is Jackson Hole, just this little kind of a dip. Then it goes over some more of the Rockies, and finally exits the Rockies. Well, the end of the Rockies is here, but certainly in this part, you come down the Wind River Basin. So the Wind River Basin is at all of the mountains between here and Oregon, blocking the flow of moisture coming from that direction. And so we end up, we have the basin here in Idaho Falls, and we get over it, and we have another low point, almost as good as the ones farther west, here at Riverton. And so Riverton, Casper, and on into Alliance, these three places are probably the best places for anybody from here to go to because they're close and they give you three pretty good spots terms of the climatology.
What about that road to Jackson, show that?
Oh yeah, this road here, we came up and around and down through here, and then up zigzagging in the pouring rain for a 30-minute drive that took an hour and a quarter, and then got into Jackson. So we'll put them in a picture. The other alternative is to go this way and out toward Riverton, which is a 200 or 160 kilometer fall. And I don't know if I can do that with 6, 7, 8 busloads of people, but
I think that's one of the Tetons there.
so you ride this thing up, you have a couple of problems. Great view, if it's clear. Secondly, if there's thunderstorms, they close this down. And then how many people are you supposed to fit in that little shack? 40? 40? 30, 40. So imagine 400 people up there with a thunderstorm. Probably don't want to be close to these wires. But, you know, before we left, the skies cleared up completely. And here I am toward the end looking down into Jackson Hole, and you see the clouds are all on the mountains. But the center of the valley is clear. So, even in Jackson, there are places that you can that kind of an environment to, and I think it would be really great if the weather was. I sort of grabbed from Google Earth a little map of the area that the Jackson is here, Teton Village is over here, and the Chairman's run up in this area. Victor is over the border in Idaho, and so I always thought I liked this area a bit because you do have a view of the Tetons in here. But of course, if you get stuck there, you can't just go across like this. You have to go all the way around and take this road that goes up and down to Jackson. The airport at Jackson Hole is right here, right smack on the center line. And there is some opening spaces in here. The place I'm going to be at is actually a school. It's got some ground somewhere up in this area. But it's reasonably quick to get out this way. It's a good highway if you have to get over to Riverton. I don't remember much about Riverton. There's just a place along the way. The next place we stopped, which is still a few hour drive away. It was a Sunday when we got to RASC Park, so we didn't go and talk to anybody downtown, but we found this little place. 470 meters north of the central axis. It's on the south side of Casper. You'll notice the spelling here. Casper is P-E-R, but the fort is P-A-R. That's because the guy's named after a lieutenant who got killed for doing something stupid. This was his actual name, but they misspelled it when they registered the city, so forever had the wrong spelling. So it's a very large area. It'll hold a lot of people. I expect they've probably done some kind of major type of...
Yeah, they have a lot of room for parking, excess parking. So
I don't remember what the facilities were like, but there was, I think, probably enough for, you know, probably to do a growing business in the gift shop. The big problem with one of these things was, you know, normally they might have a Casper Day and have 400 people, but they could very easily have 4,000 or 10,000 people that show up. If that happened, I think there were fairgrounds that weren't very far away from this, that sort of down the street, so they'd probably be like most American communities and organize something at the local fair. But then we get into Nebraska. I know a lot of you are talking about Nebraska, and every time you do, I say, well, you don't want to go, if you're going to go to Nebraska, you want to go to Alliance, which is right here, because Alliance is right here. So as you come out onto the plains, you start to run into the moisture that's coming north from the Gulf of Mexico, and so the cloudiness increases, and it starts increasing, and in fact it never really decreases until you get to the Atlantic Ocean. So Alliance is kind of your last chance. Now, that doesn't mean that, say, Lincoln isn't all that bad, where is York? York is somewhere in there. Right there.
That's kind of, we come straight down through here, and where we,
Yeah,
where
York
we
is
hit the
here.
highway, which is York.
Don't get too close.
York is a place with a lot of motels, because two main highways come together there. And when we checked last March, coming home, I stopped in the motel and said, "Have you got any bookings for the eclipse next year?" And he looked at me and said, "No, I've got nothing for that." Now, that may have changed, but, you know, in a location like that, which is getting pretty close to the center line, with the I, whatever it is, that'll run you back east and west I-90. So, and there are lots of secondary roads that'll keep you right in that. Now, Alliance, of course, is semi-famous.
So this is where I'm gonna be.
Grand Island. Grand Island's got big plans for this eclipse.
There's a KOA there, and somebody started, from the RASC, nationally, people from the east started looking up that KOA, and so now apparently there's going to be about at least members and spouses from the RASC.
Now, of course, if you want to join the metal hat crowd, outside of Alliance is what's called Carhenge. And believe me, they have something planned at Carhenge, but it's probably a little bit eclectic, and I suspect the town of Alliance itself will probably have quite a bit of, to stop people from collecting at Carhenge, because there's really nothing at Carhenge except a whole bunch of half-buried cars. And
This place.
and a souvenir shop. Yeah, I've been
You love
there.
this
I've been there
place.
3 times. Oh, you can feel the vibes.
And the craziest in the gift shop. You start talking to him, and you just go, whoa.
Yeah. Have to order 3 extra T-shirts. And this is a sort of scene in that area. These are actually the Nebraska sand hills, and they're a bit of grass. But when is within a week of the eclipse, probably.
They have parking for thousands and thousands of vehicles, so.
And there's lots of trees so you can sit in the shade during the eclipse and things like that. And so here's the rest of the eclipse track. After you leave Grand Island and St. Joseph, then you begin to zigzag up and down. A little bit of a decline in cloud here in the Tennessee Valley. Carbondale is where the 2 eclipses, the 2017 and 2024 eclipses cross over, so a lot of people will go there. The longest point of the eclipse is right in about here. Nashville, only the northern half of Nashville comes under the eclipse, but there'll be lots of people going. When you get over the Blue Ridge Mountains, your cloud maxes out at 70+%. Charleston is here, but right offshore it's clear. So if you do want to go farther east, if you go right to the coast and sit on the coastline, then you should be able to get into some of the cloud because of the sea breeze. You'll get out from under the cloud. There's a Baja, rather than half an alligator. And anyway, this one, I'm watching the Weather Channel. The bartender said I could have 10 minutes, because that's all the patrons would let them interrupt women's mud wrestling. 10 minutes is what the weather. So, what do? You got 2 weeks to go. We all know about the long-range GFS or Global Forecast System model, and you can take a look at that, and you can say, well, like this example here, which is 324 hours out into the future, 15 days. Now here I am looking at Idaho and Oregon, and this is the predicted cloud cover. Well, it's not really very heavy. You can match it up looking at 40, 50, 60% cloud cover. But you know, if my plans are here in the Idaho Falls area, I'm looking pretty good. Really good here in Jackson. Well, don't you believe a word of it. 15 days out, you don't believe it. All you do is look at it and get worried. You get 10 days out, you go back to the same model, but now it's going to a little bit higher resolution. And here we are showing pretty much the same kind of a pattern. You know, the eclipse is coming down this way, maybe this way. And so if I'm sitting over here, I'm thinking, it's a little bit dicey. I better start thinking about maybe moving over to Riverton, or not Riverton, into the Snake River Canyon here, and over here near Idaho Falls, or even into the Jackson, Wyoming area. See, the thing is, I don't want to be near the edge. I want to get out into the open. But it's still too early, 10 days out. But what you do is you watch the forecast for eclipse day at 11 days out, 10 days out, 9 days out, and 8 days out. If it stays the same, then you can start having some faith in it. If it keeps on showing this clear area, then you can use that model. So really you start to make plans when you're about a week out, and especially if you've been watching it from day to day to see that it isn't changing too much. If it is changing, you just got to wait a little longer. And you look at the successive model runs, and you also compare a couple of models, although the Canadian GFS global model is, they don't give you the same data output that the Americans do, so it's harder to find out whether or not it's cloud or not. The American models, especially if you go to the College of DuPage site or some of the other places, will give you an explicit forecast of cloudiness. But when you're 3.5 days out, this new model comes in, the North American model, and you can then compare the GFS model and the NAM with each other to see whether or not they're different or whether they have commonalities. And I will tell you right now that they'll have some areas the same and some areas that will be really, really different, because the NAM model uses a different physical system, physics model, to calculate cloudiness. And it's geared more to convection, thunderstorm cloud, than the GFS model, which is geared more to big system cloud. Oh, how did I do that? All right. Good lucky. So here we are looking at the GFS model. This is a 81-hour forecast. So here we are. It's not the same day. So here we are. Oh man, this is just a piece of cake if it's like this. 3.5 days out. Wonder what the other model looks like. Oh, well, So for one thing, it's not bringing in all this cloud down here. It's keeping it back a little farther. But it's still clear and good in here. So if I'm sort of thinking about the coast, this guy says yes and the other guy says no. I maybe wait a day to make up my mind, but more than likely I'd pack the kids up, get in the RV, and I'd start heading over towards the Snake River Valley. So but there's a lot of commonality in this system, especially in the important areas. At 2 days out, now you got to really make your moves, because unless you're in a clear area or not, or close to it, you might have to make a substantial move. First of all, both of them show cloud coming in off the coast, but it's more to the north in this model than that one. But it just says overcast. It doesn't tell you what kind of cloud that is. That may be just a big fog bank that's staying offshore. This patch of cloud in southern Idaho, which is perilously close to the eclipse track just north of it, also appears here, but we have this whole other separate piece of cloudiness, which is not in the GFS model. And this stuff up here is pretty much the same, and there's other pieces that trickle down in here. So you want to be careful. This might be nothing more than some cumulus cloud that'll dissipate during the eclipse. And you really don't know that. You just know that it's saying there's going to be cloud. I'll give you an example. Here's one, hypothetically, you're being up all night, you're worried about things at 12 UTC, which is a full infrared satellite picture. And 12 hours later, the model is saying that that cloud is going to be moved out so that it's just catching this corner of Nebraska. So it says that's going out of there, but it's brought in this area cloud, which might be this one moving down, but it's also got these other bits and pieces. Plus it's got this thing sticking up, which is probably a part of this. So there are some areas where you got to be careful, because this eclipse track is coming across like this. So you might be okay in Alliance, and you might be okay if you drop back into Wyoming here. Well, the actual situation, this is 18 1745. Here's what happened. So this is close, but this is what I mean about maybe you want to push it away so with this one in all probability. So you kind of have to be a little careful. When you get to the eclipse day, well, you just sit back and take what you've got, unless you're very close, and that's where you have to use satellite pictures. Small cumulus clouds, even medium-sized cumulus clouds will dissipate. Here's a picture of cumulus clouds in 98? 98. You were on the island?
Yeah, Aruba.
Aruba. Yeah, you were on the island. Or maybe that's Aruba there, I think. Anyway.
Yeah, where the clouds are?
Yeah, that's the band of clouds. We were on a ship and had to get out of that stuff.
It came right over top hours before the eclipse.
But this is before the eclipse. Lots of cumulus here. This is after the eclipse. Even Aruba here, the cloud band that was coming up onto it dissipated. Normally that doesn't happen over the ocean, but if it's not too strong a dynamics driving it, it would be fine. But cumulus all disappeared except for the stuff that's right on the mountains caused by the air pulling up the mountains. So it really does disappear, and it disappears about a half hour before the eclipse. Now I'm going to talk just basically, you ask yourself this question. You're going to remember the hassle about finding a place, the last minute, the success, the way the kids enjoyed it, the way your grandparents enjoyed it, or your parents, their grandparents, if there were along. You're going to remember this sort of thing on a ship, watching the eclipse, everybody around you, the celebration, or is this your memory? And if this is your memory and you see a lot of eclipses like I do, are you going to even be able to say what eclipse that was? If it's the only one you saw, then maybe this is what you like. But, you know, this is one of my favorite eclipse pictures because that tells me an awful lot about where I was and what I was doing and what other people were doing, and the fact that it was absolutely stunningly sunny. And so think about what you want to remember. If you want eclipse pictures that look like this, I mean, it takes work to get a good eclipse picture. You have to do a combination of many images, or you can just go online and steal somebody else's. I mean, they're all going to be there. These will be there too. But this is one thing to think about. You are the only one who's going to take that selfie with you and your wife and your kids and that son behind you. Nobody else is going to do that for you. And that might be the great memory that you have. Certainly the one that goes on your Twitter page. Video is a dead loss. Video is fun, but video will never show you the details in the eclipse. Video won't even give you a picture that good because video cameras saturate too easily. And you can zoom in and out and control the exposure and things and see various parts of it, but you don't get to combine them all together the way you can with that. So if you want to have a video, do a time lapse with a regular camera. Shoot a picture like I did with that Aurora picture. This is a 2.5 minute eclipse or 2 minute eclipse. You take a picture every 5 seconds, you got a nice little video. And doing coronal stuff takes a lot of work. So there are free programs out there that will run your computer for you while the eclipse is there. It'll hang into a GPS, do all the timing, do all the calculations, start the 1/8,000th of a second at the right moment, and switch over to the 1/150th of a second when it has to, all that sort of thing. But here's a few hints. Plan. Go outside, have somebody run the watch for 2 minutes and 10 seconds or whatever your spot is, and try to do all the things you want to do. And do it 10 times until you've got it right down. I'm very experienced at that. I've never done it. And my pictures show it. My wife does it though. Have a plan B. Like all of the people in Svalbard where that nice cold picture was taken who had all that computer control. And guess what? Computers don't work at -21. Because computers work, the screens don't work. So they couldn't do anything because they couldn't read what was on the screen. If you're with somebody, watch for half the eclipse and photograph for half the eclipse. So at a 1 minute interval, your turn, give me the binoculars. And that way you get both. There's three things to good photography. Vibration control, and that doesn't mean a tripod. That means live view, and for the older Canon cameras, the special settings that reduce the vibration of the shutter. Focus is extremely important. But we also found out that shutting off the switch that controls the vibration, the movement, is also essential. Because when you trigger an eclipse, it immediately starts to correct for any motion. But there is no motion if you're on a tripod. And what it does is there's a little streak of light as this little sensor inside tries to stabilize your camera. And then it's stable and you've got your picture. But if you try to take a picture of a star field, they all have little hooks in them. Shut the stabilizer off. Judy will tell you more about that if you want to ask her. So shut off the image stabilization on your camera. Draw a picture. I've showed you this before. This is Judy's picture of the Svalbard eclipse after she took all those pictures. But it points out what she remembered herself with notes about that eclipse. And she has them for several hundred other eclipses. This is a video of, I've showed you this before. And this is, I'm only showing you this because it's 18-second long eclipse. You can see in video how the shadow forms, and the sun in eclipse now moves across the shadow until it comes out across the other side. That's the only way you're going to see the shadow, and if you've got a little bit of cloud in the sky, that's even better. Eclipses without clouds are boring. So any eclipse video longer than about 20 seconds is boring. That's why I say shoot time lapse. Then you can speed it up. You see everything. You see the shadow. It's going to be much slower moving in this coming eclipse. Instead of 18 seconds, it's going to take 10 times as long or 8 times as long. It's much more dramatic when it happens quickly. Take a diffraction grating. $2. $2. And you'll see this during the eclipse. I'm not even going to explain this to you. Jerry will do that, if he understands all of this. But this is the spectrum of the corona in the various elements, these circular areas, plus hydrogen alpha, hydrogen beta, hydrogen gamma. These are the hydrogen lines showing up along with some of the calcium and other stuff that's in there, in the inner atmosphere of the sun. For safety, well, you could be like the Australians do. And you laugh, but this is what we did in 1979 here. So Ralph Chu, who's the world's expert on it, says it takes several tens of seconds to do temporary damage to your eye. For us old folks who have not very transparent eyes, we no longer than others, you have to look at the sun without protection. And I'm going to tell you why. So, when you buy your glasses, every U.S. manufacturer now has ISO certification. But not all of them make the same quality. The stuff that the RASC was selling for the annular eclipse were terrible eclipse glasses. I particularly like number 14 welder's glass. Very pleasant, so buy them now while you can. Because it takes time to get them. You can't just walk in and get them. Or you can buy solar film, you know, it's like $150 for a sheet to build 50 filters. And that's really optically perfect stuff.
One of the things that we found when we saw the annular is we have that stuff that's really silvery as opposed to the black stuff. Well, the silver stuff, just the dynamics, the light is coming off the edge and bouncing off your eyes, and you're basically seeing your eyeball sort of projected on this film. And so unless you've got it totally covered up that no light gets on it, the inside just becomes a reflection nightmare.
That's why I like welder's glass. It doesn't do that. But whatever glass is, you got to wear them in order to make it effective.
The best was we had some of that. It looked like black film, right? And we were looking through that, and we didn't have any of those issues.
This was the biggest.
Oh, this guy's right.
That was a tough job getting that camel to wear eclipse glasses. Okay, reflip won't damage your eyes. When you want to look at the eyes, is the diamond ring phase, both going in and coming out. Are you going to put your eclipse glasses on right away? No, you're going to spend 5-10 seconds watching the diamond ring, watching it disappear. I mostly suggest you watch the diamond ring at the end, because if you watch it ahead of time, your eyes are dazzled and you don't see the corona. I know people who put red glasses on to darken up their eyes before the eclipse and have been able to see the corona out for 3.5 diameters. For most of us, 1.5 will be able to see it. So if you dazzle your eyes, you're going to see even less of that. So do you look at the diamond ring? Of course you look at the diamond ring. And then you put your glasses on. And don't try to do too much like this guy. I've seen so many people have 4, even 5 cameras. Fred Espinak's famous for that. And 2 of them won't work, 1 of them won't maintain focus, and the other 2 get them great pictures. And so, there we are. The maps and things will be on my website right at the top. The weather comes from the College of DuPage, which most of you use for regular observing. And Xavier Dubier's eclipse page on Google Earth will give you the maps and all of the times and everything else along the way.
I sometimes wonder if people are getting data out to their laptops or their phones. I just wonder how the cellular network down there is going to be able to handle it. They want to go to the same websites doing it all at the same time to check the weather.
But remember, the National Weather Service will have a special eclipse forecast. AccuWeather will have a special eclipse forecast. The Weather Network or Weather Channels will both have a special eclipse forecast. You'll be able, well, I'm hoping they agree, but if you don't like it, change the channel and find it better. So good luck next year. I anticipate that in the September meeting next year that we'll all be telling about our eclipse adventures and showing our eclipse pictures. And probably should devote the entire meeting to that. So start preparing now. You know where the weather's the best. Lock in your places like Stan has if you can. And then do your movement as you get closer to the event. So thanks.